Hi, good evening, everybody watching out there. Tonight we are going to be talking about water quality. Something that I've heard a lot about during these sessions, but known very little about, actually, to be honest. So it's all good information for me as well. We're joined by two of our regulars. Rob and Richard are here tonight, and Damon and Ricky are two new guys that are joining me because they are experts in this field. So I'll let them introduce themselves now, and then we can crack on. So Richard, Rob, do you want to start off?
Yeah, I'm Richard Burrows. I'm from Mid Wales Plumbing Heat and Supplies. I'm the director there, regular on the show, and looking forward to tonight's session. Rob.
Yeah, hi, I'm Rob Berridge. I'm one of the directors of Heat Engineer, another regular on here. I just give my opinion as much as I possibly can.
Ricky?
I'm Ricky. I'm the owner of 𝗵𝗲𝗺𝗺. You might have seen it on the social media platforms, the products we put on the market about 3 years ago. So I took water quality to another level just as a basic engineer, really, and come up with 𝗵𝗲𝗺. And here we are today talking about it. People are buying testing kits off me, flushing kits, VDI kits. And yeah, I'm here to help everyone out, really, basically.
Brilliant. We can go into all that in the session. Damon?
I'm Damon BPHR, just an installer who don't use chemicals.
I'm just an installer.
Just installer.
Not just an installer.
Just a standard one.
Bog standard installer.
Thanks, guys. Thank you for that. So let's start off with, what does water quality mean? What are we actually talking about here? Give it to us in a bit of a nutshell to explain to anyone who's not clear on what it means.
Go on, Rob. You're the host in one.
Well, the bottom line is that water is the very, very cheapest component within a system, and it's the one that we take the least amount of care about. It's it beggars belief that modern science has kind of really negated this absolutely crucial part of the system. And when the science is presented, almost now becoming mainstream, certainly mainstream across Europe, but when the science is presented, it kind of almost seems to be pushed to the back foot, and we don't trust it or anything like that. Now, we've never really understood that, but we live in a world now where everything needs to be going chemical free. Everything seems to be needs to be less emissions, we need less, not more. So surely the fact that we've got this science out here and we want to look after this quality, let's face it, any corrosion in any system is going to cause you problems. I think there was a report out a little while ago that around 84% of all boiler warranty calls were down to water quality. I mean, frankly, that is just atrocious. And if we've got solutions that we definitely have got here, why aren't we using them?
Yeah, 80% it was, wasn't it? I saw the report. It was 80% of all heating system breakdowns are due to water quality issues.
Water expansion, I'd say, water's biggest part of your system, and cheapest part if you're doing it. It's not. It don't have to be expensive to do. I mean, if you're filling with, in certain places, you can fill with tap water. Yeah, if you're filling with resin, once you've got that initial outlay out there, it costs me about 10p a litre. So on an average 100-litre system, it's no more than a bottle of inhibitor, £10-ish for a decent one. So it's not that expensive.
Yeah, break it down a bit more, because I don't think everyone. If Ricky just goes over what the different types of water, keep maintaining water quality is, and then go from there. I think.
Yeah. So when you go down the VDI route, you can go tap water. You've got to monitor it. So I say to everyone, you need to buy a decent test kit. So 300-400 quid and a decent test kit is going to get you something that is going to last, and it comes with all reagents, so you can retop it up. But that's the start of the process. So you might live in, obviously you do live in Wales, and you could probably fill with tap water and you'll be fine with it. But you might go to London, it's a bit harder. Some parts of Norfolk a bit pretty hard. You would need to be filling with resin, and then you've got an initial outlay of about £1,000 to invest in the kit. But like I said to Damon the other day, it's like buying a gas analyzer. Everyone, it's too expensive, but you've got to buy that gas analyzer to do your job, haven't you? And then it costs you 80 quid a year to then calibrate it, which isn't a massive expense. It depends on your area, what chemicals you've got in your system. You might need to replace the resin a bit more, but we sell like a loose resin system, so it's not a massive expense. It's 130 quid for a top up of a unit that you should get 5 or 6 decent system fills out of it. But it's just that initial outlay, and I say to everyone, it looks daunting at first, but once you've got it, it's there for years to come then.
Yeah. So what's the resin? Is that, what does you mean by resin? What does what?
Blue piece of this, isn't it? Here you go.
Is one I made earlier.
That's an ion exchange resin. So it's got a higher content of anions, which changes obviously the quality of the water. And that is for a big bag, sealed bag, it's £125, I think. And you put that in your resin filling unit, clean your water through it, make sure your parameters are in the right region, and then that just fills your system.
So the beads attract all of the mineral particles, if you like, within the water to the beads, and they last a certain amount of time. And I think that there is some progress now on actually regenerating these beads, isn't there, Ricky? You were talking about this before about recycling the beads.
Yeah, I think they have looked into it, and it was something to do with the acid that was involved, and it was quite bad. But we do regenerate.
This is the only byproduct, isn't it, of using VDI system as opposed to,
yes.
I mean, the whole idea of draining down a heating system that has got a lot of inhibitor in it or etc. straight into the water network or into the drainage system is clearly not a wonderful thing. And if we're fitting 6,000 boilers a day and they're all getting flushed out and this chemical is going into our water table and system, eventually that's getting back to our kids, our wildlife, our everything that's there. And if somebody says to me, if someone ever said to me that it's safe, I say, well, there you go. There's a bottle of inhibitor. Drink it, and let me see what you think, because I'm pretty sure they would.
Yeah, that's the only bad thing about it is disposal of it. It comes with a disposable bag, and they recommend just putting it into landfill, which it's not perfect. But then you've got to look at how many bottles of plastic bottles are getting into landfill.
Well, also it's a similar type resin to the main product. What you get in water softeners. And that kind of thing, and I've argued for this at some point. I mean, they're silicon balls at the end of the day, isn't it? Why can't it be used in sort of aggregate building works and stuff like that? I mean, there's future things for this to recycle it and make it 100% pure, if you like.
Chuck them in a passive house.
Yeah, why not? Yeah.
You don't even need to use a resin. So as long as you're checking your water and making sure that's all right. I mean, like you said, Wales perfect for it. My only issue with filling with just tap water is if you've got the high hardness. So then what'll happen is it'll cook out somewhere. It's either going to go out on hardest part. So it's either going to go in your heat exchanger, it's going to sit in your plate heat exchanger, or it's going to sit in your coil. And at them points, you're going to lose efficiency over time.
Well, I've seen stainless steel heat exchangers, which, as we all know here, work right the way across the pH range from 1 to 14. I've seen stainless steel heat exchangers actually rot out because of the calcium content within the water. And this is a pretty serious scenario. I've got 2 projects in London, like commercial projects that I do, and both have used VDI, and both of those water systems have been checked after a couple of years, and they're absolutely no build up whatsoever. The one thing that I would say, and this is a really, really scary statistic, just 1 millimeter, just 1 millimeter of scale on a primary heat exchanger can lose 10% of its efficiency. That's a massive amount. Yeah, massive, and quite scary. So I know there's going to be questions, isn't there, later on as to why this is, and how do we sell this to our clients? We've got to move forward. If we're going to go win this efficiency race, we've got to get out of this buy cheap, buy twice mentality. It's got to be done correctly. It's got to be done. Pay the money up, get your testing kits, and get it done, and actually gets longevity into these systems, because that's exactly what's going to happen.
It's a 3-stage process. It's flush properly. Make sure you flush that right. Make sure your system's right. If you're using inhibitors, no cleaners or anything left in it, get that all out. Then fill it properly, whether you're using an inhibitor or whether you're going VDI. I prefer the VDI. And then test. Testing is something that's missed drastically by all food aboard, VDI products, inhibitors. Testing's never brought up. I mean, now all you get at minute is even on the new BS standard, they're asking for They're only to check inhibitor level. They're not asking you to check anything else. They like ion levels because they're selling magnets. You know, they don't tell you any parameters that you need to check apart from use a gimmicky app, and that app won't pick another brand of inhibitor up. It'll tell you to add more inhibitor if they don't sense their own brand. And then you add in another bottle, you could end up with 2 or 3 different bottles of inhibitor in that system. And what's that going to do to it? All you're going to going to perish because it's a big miss.
That's my biggest problem. People are buying test kits off me, and I can only offer them so much guidance. So most inhibitors use molybdate, but there's a big manufacturer that uses nitrate, but they're rebranded into own branded into 𝗺𝗿𝗄𝗎, Williams, Poaching, like instant brand. Can you explain to the listeners what molybdate is, Ricky, so they got an understanding? Molybdate's one of the main ingredients in an inhibitor. So you look at all your big brands use molybdate, and I think the only company that actually disclose that information without harassing the department is 𝗺𝗏𝗧. So 𝗺𝗏𝗧 actually say on their bottle it's our ideal range is within like 100 to 150 ppms of molybdate. So they're the only company that actually put it out on the test kit. Wow. But there's not a bottle of inhibitor in the UK sold off the shelf that has any test data on it. Wow. So you can't obtain that either. No. It took me 5 days to get information from a merchant to get to the manufacturer. Wow. To get the data, and I went through sales reps. Then I ended up speaking to the scientist behind it. Wow. But it shouldn't need to be a phone call. It should be on the bottle. So we can see that. I mean, the first thing that you see when you walk into any plumbers merchants now is just shelves and shelves of inhibitor and chemical, isn't it? That's the whole thing, and nobody really understands how to implement BS7593 correctly and actually dose correctly, and then, as you say, subsequently test for passivity within the water. I mean, I think that it's a science that, you know, if we as engineers don't get on board with and don't ask, then I can never see us getting over this, black sludge, poor quality, oxygen ingress systems that we've been having to deal with for the last 40, 50 years. And to my mind, that just proves that chemicals either haven't worked, or the education, as you're pointing to, around them has just not been freely available. No, I do think they say you can't overdose, but I do think you can.
As an industry, we've been bred to drop a system, get that water out, drain it. Chemical flush, hot flush, with boiler connected, all that rubbish is going through your boiler already. Then cold mains flush, no test to check whether you've got all that chemical out of your system already. No checks to say whether your radiators are actually testing against your tap water that you're running through to check, see if that's all right. Then pour a bottle in, it'll do 150 litres or 15 radiators. That's the education that we've got from chemical companies for the past 20 years. And then their answer to it were add a magnet. But surely the fact that inhibitors should be stopping anyway what that magnet's catching. I mean, they like high ion levels on the testing because they want the magnets to work. That's how I can see it, and that's my view on it. They don't actually care so much about the quality system, and to me, it comes down to sales, and it might just be like I don't know answer, but it's. I think actually what I was told one day is we're not clever enough, mate. that's the nutshell of it. Is but you laugh, but that's the truth behind it. Is that I think most installers are deemed as not clever enough to do all this, and that easy solution is just taken up by so many installers out there. Is just chuck a bottle of inhibitor in, and if they're not sure, chuck another one in for good measure. But if you look at some of the systems that get pulled up, I mean, Paul Hull pulls a few apart, big commercial systems, and they're full of inhibitor. They're literally coming out white. Do you know what I mean? And nothing about that is saying that that's the right thing to do, is it? And that was a project it's only brought to light now because of long warranties. So these boiler manufacturers, if longer warranties on boilers wouldn't have come out, this won't be a problem. The problem is that longer warranties are now boiler manufacturers are going out and saying we're not changing that. That's down to water quality. Then they're being pulled back, and they're like, people are like, well, I've never had an issue. Why now? And it's because they're testing it because they don't want these longer warranties. Exactly. I've heard that as well. I mean, that particular project you're on about there, Rich, that's a project that I worked on with Paul.
The place was riddled with plastic. All the primary pipe work and riser pipe work was all done really, really well. It all looked really good. But the fact that it had been overdosed because they couldn't solve the problems of oxygen ingress and stuff like that into the building, every single balancing valve in there, and we're talking, some of these balancing valves are sort of, your DN100s, DN125s. I mean, we're talking really, really expensive kit, and all the glands had failed in them. They're not serviceable. So you're probably talking on this now, just on the primary side of it, 20 or 30,000 pounds just to replace these valves,
just to fix it.
Exactly, just to fix the problem. And this is the point: is surely prevention is much, much better than any kind of cure. Just because it's commercial doesn't mean to say it's any kind of different. It isn't. Water's water. But something I really wanted to pull up here is that as we're starting to move towards lower temperature systems, we've got to be a lot more careful about how pH goes, because if you're running pH coming out of your tap in London at about sort of 6.5, 7, probably about 7, and you really want, if you've got different materials within a system, if you've got aluminium heat exchangers, if you've got iron pipe work and copper pipe work built in the system, which a lot of these systems do have, your pH range where it's going to be passive is so narrow. You need to have that pH at around 8.5, to get that passivity within the building. And the old way that we used to do it, remember when I was doing my apprenticeship years ago, the old way we used to raise that was to boil the water up. And once you boil the water up, it raises the pH. But with low temperature systems, we're not going to be doing that, and we don't even have the option. So if anybody's moving on to working on heat pumps and that kind of thing, where you're working at 45-degree flow temperatures, the pH you're stuck with is the pH you're stuck with. So you've got to start thinking about treating it. So that's a big issue. I don't know what you guys can elaborate on that.
Degassing at some point, I reckon.
Yeah,
so get oxygen out. Remove oxygen, you're not going to have an issue, are you? It's just getting that initial start on a low temp heating install. I'll just raise it up after I've filled, cook it for as long as I can, ramp curve up, open windows, leave it. On a system boiler, I'll put it on, do that first, put it on the hot water circuit, so at least then it's getting a chance to be able to come on. But like I say, heat pumps are going to be a little bit of an issue, and then get yourself a portable degasser.
Imagine the thousands that are out there already, though, Damo, isn't it? Do you know what I mean?
That's the problem. It's the same market as boiler market soon.
We're gonna have big problems with water quality on heat pumps. That's a fact. So
definitely.
Yeah, I'd like to see the data on. The Germans said to me when I used to supply for another company, they said they don't have issues on low temp with Demon water.
No.
They said about 8.2. The VDI allow 12 months for it to get up to that standard, and then they say you might need to implement some, and it can be as little as a spoonful of pH plus, but I say to people, you're playing with fire. If you're going to start pissing around with pH plus and minus, you're really playing with some chemistry, because you only need like 100-litre system. You literally need a teaspoon and it'll just go.
Yeah, I don't know if I said it on this group before, but I had some property in Germany, in Berlin, and it was bonkers. This building was built in 1954, I think it was, some 54 or 56, and it had, or even when I got rid of it 2 years ago, it had the original radiators in the system, all the original pipe work. The original boiler was in the system. The only difference was they changed it from an oil boiler to put a gas burner in, and that system had never ever had chemical in it in its whole life. And I was lucky enough to turn up there one day when the engineers were there and they were doing the water treatment, which they do out in there as a commercial enterprise. They do it once, I think it's either once a quarter or 3 times a year. Luckily, one of the guys spoke really, really good English, and I had a chat with him. And he said, I don't understand why you guys don't work on this VDI level. He said, we've been using it for decades, and it's just the answer. We don't. He said, look inside this pipework, and he showed me a valve had been taken out. He showed me inside this pipework. It's like, wow, there's just nothing in it. And all they were doing, literally, once every, say 3 times a year, they would go in there, and they would put the resin box on this system, and they'd run it through, and if they had any kind of dodgy readings, they would just remove like 25% of the water quality content, and then refill it with new, and that was it. That was the new industry just on its own of just actually water quality maintenance.
So can I just ask a question about what you just said, and going back to the resin, the VDI, I'm trying to understand. The VDI system doesn't go into the heating system, is it? You just said resin box, Rob. So do you put the resin to flush water into the system?
And your water just passes through and it passes over the resin, and the ions in the resin change the water, and then it just comes out one end.
It's like a canister, yeah. So you have a metal canister, and it's full of the resin, and then what you do is you pass your heating water through the resin,
so
and
you
then
fill
back
up
into
through the resin.
circuit.
Yeah, you can have on-site top-ups if you want that are sat. He's got one here that'll sit on site. So if they need to top up, you can top up through that. You can get mobile filling units that you'll plug in and do it. You can get 𝗿𝗿𝗄𝗃 like cell anodes that you can have at 𝗃𝗿𝗄𝗃, I think it's called, that'll keep it in. So there's a lot you can do. Like I say, you can add anodes as well to the system.
Okay.
That's a little top-up unit that we've got. So
okay,
literally the resin fits inside this tube. You've got cold water coming in and resin, nice conditioned water coming out.
Okay, so it filters in through one side, out through the other, and then goes into the heating system to then be your water within your heating system.
Yes, yeah, that's it. Yeah, simple as that.
So instead of using inhibitors, this is the way they fill the heating systems, basically.
Because the inhibitor goes into the water, doesn't it?
No inhibitor. So it's fresh. So the water is chemically adjusted.
In the other way to do it,
yeah,
if you're using
a radiator or a top-up.
Right. Okay. So the inhibitor goes within the system, not with the VDI, but in what most people do, they put it into the system so that it runs around and doesn't keep the system.
You use your resin in line with between your water connection and your boiler connection, so it exchanges it, and then you can remove it, or you can have them on site and keep them there, depending on what your client wants, how big system is, how much money they've got. And
cool. We did just have a question from Denzel Clough, who has said, is it possible to achieve, if an old system has had years of no treatment, is it possible to get that up to spec again, ever?
Yes.
So,
yeah, depending on your quality of your radiators, if they sometimes they break down so much, there's no point in you need to replace them. But more often than not, you can, if you do a proper flush on your system and then treat it right, it's fine. And you'll never stop corrosion, but you'll slow it down to its slowest form. I find doing the non-chemical way. My issue was we're seeing chemicals being used and seeing state systems that chemicals are on, thinking that this can't be right. Like, well, isn't this supposed to be preventing it? Like say all we've ever been is pour a bottle in and walk away, and
Rob's probably got a lot of evidence from working with Simon on the bigger builds, haven't you? Down in London, they go in and condition the system, so they'll go in and filter it. I'll let Rob explain. He's been on site more.
Yeah, they don't. I mean, literally, you can't stop corrosion, but you can remove scale, if you like, that's in a system, where you can remove the bad water. But what the VDI will do is it will just stop it getting any worse. Once you've created something that's passive, as long as the existing pipework is still sound, and let's face it, on a lot of the commercial projects, it's all iron pipework. It's all kind of, code 4, as we used to call it, or even a code 6. The blue code or the red code of pipeworks, that 𝗵𝗲𝗁𝗲𝗃, I think it is. That pipework is pretty bulletproof in a lot of cases. It's I haven't seen in a long time now of anything that's actually rotted right through. I do see fittings that have gone before I see some of the pipe gone. But yeah, you can pretty much stop it in its tracks, and certainly improve the longevity of that system by a vast amount.
And you talk about testing. So the water testing that you do at the beginning. So let's say you're using the VDI and you do your flush, and then you fill your water, and then you test it. Do they have to test often? Whenever on the boiler service, or
with my VDI, I test and then go back after roughly about 2 months just to check, see if everything's all right. Then I'll test every service. So when I'm flushing, I'll test against tap water. I use a turbidity tube, get it coming out rad by rad. If rads are that bad, sometimes you need to take them off and flush them. I don't get my frustration with flushing is when you're fitting a boiler, the flush, you should be getting that boiler to a certain quality of water before you're putting a new one on. This whole industry, this whole idea of, oh, they didn't want to get a flush or a power flush is extra, like that should be included in your quote to do. Like you shouldn't just be doing that. You should be signing the boiler off as that water's fine, whether you're using an inhibitor or whether you're not. Oh, they didn't want to pay for that, so I didn't do it, and that's your excuse for not doing it properly. You flush properly, rad by rad, get out, test against tap water. If you're using chemicals, get rid of them, test and make sure all your chemicals have gone. Chemicals are the worst thing to leave in. I mean, how many systems you go back to and they're brown and they've got that smell and it's just eating away, and you know you're having problems with your auto-air vents, you know you're having problems with all your seals in your boiler just because you know there's a chemical in there. Then just test your water after. I take my conductivity, my iron level, my hardness, my pH, and I'll do that even on inhibitor. And I'll also test for molybdate on inhibitor. Because I also want to see what's going on. You might have inhibitor in that system, but you might also have 100 parts per million of iron in it. That's no good, no matter what they say, whether that are clear or not. That's not good in the system. You know there's a problem somewhere if you've got iron levels that high. Yeah. So testing is the main bit that gets missed for me. And I think
I always say to my customers, testing should be done from day one. So as soon as you commission, do a test like 20, 30 minutes after you put an inhibitor in, or just before you leave site, doing the test, get your parameters, your molybdate level, your iron, your pH, and that's your data then from the start of that system. Because you might go back a year later and someone's been round, dumped the system, they've had the filling loop open, topped it up, but you don't know what the system was like when you left it to compare it. So you should always take your data from the start. And then you usually looking at water. If you've got an inhibitor in it, you've got high conductivity. So if you know that's back down to tap water, you know something's happened to the system, they've drained it, something's gone on, and you question them. You might get there and, oh yeah, we keep topping it up every 3 days. And then you know your boiler's probably going to be scaled up. I think we're about 220 ppms of hardness in Northampton. So you know that's going to be scaled up. Then you've got to do another, like a chemical flush on the boiler. But it's what I say to people. All these new radiators are on the market now, these tall, vertical, bathroom towel rads, they're pain in the arse to flush. If you're aggressive on that. Yeah, if you're putting an aggressive cleaner in.
Yeah, nightmare to get it out, isn't it?
You won't get it out. You can sit there all day and flush a towel rad and it'll just hit about a third of the way up and it's gone straight back out. And that
ideally close one of the sides off and take bleed off. Put like a connection on with your nose and blow it.
Yeah, you can flush them out that way. All these now,
radiators, when you go to bleed them and you're flushed, you'll bleed it. You're always going to get that bit of crap that sits at the top of radiators.
Yeah,
flushing
it's a rush job now, isn't it? Everyone wants to be boiler on, quick flush, and they're done.
It's an extra on a job, isn't it? For the job where it shouldn't be, because you get decided.
I think you're starting to get a lot more discerning clients now, and as I say, as this, I mean, this is new. This is a new understanding for us in the UK, and fair enough. You know, it takes us a while to catch up with these things, and that's fine, and it will take years for this to do. But eventually, I think it will be the industry standard to do. And you know, if we have to get out of this buy cheap, buy twice culture, we have to, and it's the only way we're ever going to do that is with guys, you know, like us that you know, I don't install anymore, but I specify this stuff. I won't do a project without it. I've now got a lot of repeat business because of it. I know you get a lot of repeat business because of it, Damon. And this is the way. And it only takes a few more of us to actually get this ball rolling. The public starts speaking to each other, and they say, "Oh God, I had a new boiler fitted last month," or the system is rubbish. Is black sludge all over the carpet, or something where somebody tried to change a radiator we wanted to get done, or my bills are this amount of money and yours aren't, and why is that? Once the public start talking to each other like this sort of thing, which is going to happen, that's when it gets. And as soon as you win the hearts and minds of any public, they will change any policy and any way of people working very, very quickly.
The other issue you get with it is warranties. Boilers ask for, you get boilers now when you fit in a certain filter to get extended warranties. That certain filter is a rebranded a chemical company. So that they're intertwined in more than just chemicals. They're big on boards. Some industry like 𝗵𝗲𝗁𝗃 and whatnot, it's not a coincidence that certain things get said and certain things happen to benefit certain companies when you're in influential positions. So you have to see a change from them themselves. It's Ideal don't want you using it, 𝗵𝗲 don't want you using it. I think Valent might be changing now. I only fit 𝗵𝗲 allow me to do it. They embrace that. They'll let you use inhibitor too, but they'll let me do what I want to do. I think 𝗃𝗃 are getting into it now. So there's more boundaries than just trying to get your customer to do it. You have to try it. You've got to go to a boiler manufacturer that'll let you do what's best. And so
my biggest gripe is now with boiler manufacturers selling chemicals with the name on it. And then you get this is 𝗵𝗲𝗁's new water quality. So that's the benchmark. That's the VDI in that you've got to fill that in for a 𝗵𝗲𝗁. But you open a benchmark and it's one of the biggest brands in the country, and it begins with 𝗃, as the kids say. You ring them up saying, I've got your benchmark, I'm just going to service your boiler, but I've used your inhibitor. Can you give me the parameters so I can fill the benchmark in? Sorry, I don't know what you're on about. Well, how can I fill the benchmark in for your boiler, for your service document, if I'm using your chemical? Oh, we don't know anything about that. Sorry.
And you would think that after.
Go on, I'm sorry.
And you would think that after 40 years of actually putting this chemical in, that they would know, wouldn't you?
Well, you would, yeah.
Water quality that they're asking for in boiler manufacturers manuals, and then you add an inhibitor in, you're not actually meeting what they're asking for because the pH is too low or other parameters are out.
No one knows.
How's that meeting? Even they don't know. They're printing something and then telling you to add an inhibitor, but then you can't meet it adding what they're telling you to add.
So does the benchmark say that you have to use inhibitor for most boilers? Is that what the benchmark says at the moment in the UK?
It asks for your content and brand, doesn't it, in the back of it?
Yeah, well, they won't let me do the 𝗵𝗲𝗁 on the benchmark online app, so I had to go and get it changed so I could add, because you had to add an inhibitor, like to be able to go online and do it. So they've changed it now. So if you select a 𝗵𝗲𝗁 boiler, you can just put down that you're not using an inhibitor.
We are putting on it for my sins. I know I get a lot of stick for this, but I actually sit on the systems group of the 𝗃𝗃𝗁𝗃, and I know that it's not popular from a lot of people. But the bottom line is that, you know, we and the systems group, we've produced quite a lot. We've produced a lot of papers, and it's been, I've got to say, the 𝗃𝗃𝗁𝗃 have been incredibly hard working in getting some of these papers out. But one thing that we did do, and I was adamant that this had to be the case as a member, was to say that, you know, BS7593, and this is listed in the guidance now from the 𝗃𝗃𝗁𝗃 paper to government, is that it's BS7593 or other accepted manufacturer water treatments, and that's actually been included now. So that was a big fight, I've got to say to everybody, that was the case. So things are changing, but it does take time, and that's the thing. So yeah, it's difficult. I can see there's a load of questions being thrown up on the
It's vague. If you look at like the Austrian one or even VDI, it's not all just VDI. Austrian have got their own standard as well for it. Austria, not Austrian. Theirs is more in depth and more scientific and like exhaustive and gives you parameters. You look at ours and it's basically top up, refresh it every 5 years.
Yeah. Well, we're all here to learn, aren't we? I mean, I see this question here. Was it Rob Sale? So I used an instinct inhibitor, and after flushing, when I went back to do a boiler service, the water quality was dark black. Scale Master make the Extinct and 𝗵𝗁𝗁𝗁. I don't know who 𝗵𝗁𝗁𝗁 is. Is that a merchant? Is it? The stuff is shocking. Stop using it. Rather pay extra money now for better quality inhibitors. I'll tell you the one thing I would say, which not a lot of people we haven't mentioned yet, is that one of the biggest causes of a system water going dark black is oxygen ingress.
Yeah.
Exactly that. Whenever you've got oxygen ingress, I mean, this is the thing. I mean, this is obviously quite a big subject to get into now, but for the guys listening, just do a Google search on Henry's Law. Just look up Henry's Law and have a little read up about it. But just to give you a quick example, if you take a glass of water to bed at night out of the tap, and you know it should be if your water main's buried deep enough and it's 750 mil deep, it should come into your house at about 10 degrees. Now, if it comes in your house at 10 degrees, you take that glass of water up to bed and stick it on your bedside cabinet. When you wake up in the morning, you haven't touched that glass. What's on the inside of it? A load of bubbles. And that's all your dissolved oxygen that's coming out of the water as the temperature of the rest of the system rises. Now you imagine your heating system's going hot, cold, all the time. So it's releasing all the oxygen, and then it's pulling it all back in, releasing it, pulling it back in. If you've got anything that is open on that system, like automatic air vents, I mean, this is a real bugbear for me. Automatic air vents, they're for filling and commissioning purposes only. They must be kept shut once you're fully commissioned. That's the point. A lot of people think you just leave them open. I saw that JMR Heating has asked that.
Yeah, I was going to say.
Yeah. Just that they're literally for filling and commissioning purposes only. But as soon as you get that oxygen ingress, and this is why this is a subject for another day because it's huge. Expansion. If you don't get the expansion right on that system, you are going to start causing oxygen ingress to come into that system, and that's what causes it. It's oxidization at the end of the day. I mean, if you look at what water is, it's H2O, so 2 parts hydrogen, 1 part water. That's it. It's all gas in its purest form.
What often don't get said is systems that are left over summer not running, and water's just sat there.
Massive, yeah.
Without the pump running, and you go and turn it on. Or if you took a water sample after 6 months of not using your heating and just seeing that stud water, you'd be surprised even with VDI how it'd be like. They need to, even if it's running just once a week, you need to turn that heating system over.
I think I've mentioned this to you, haven't I, Rich, in the past about open firm. I'm sure they could put an anti-stagnation protocol in the back end of a thermostat. And I was speaking to someone today who's probably he's big in the bacterial
or have cooling, so use your heating circuit for cooling during the summer, and obviously keeps it running as well, because it's just sitting there also. I mean, we all know we all know this, anyone that's been out there on the tools, we all know this happens. So the important steps to combat it is just spend more time. Well, just do research, isn't it? You don't have to take any of our word for it. Just literally research some of the methods that are out there for, preventing system corrosion and heating circuits, and you'll come across one of us. So that's kind of where it's come down to, whether it's something Rob said or I've said or Ricky, a few articles Ricky's done, or some of Damo's installs where he's used VDI methods to, treat the water, to make, and the important thing is what I look for when I go on social media and I look at these guys and I look at some of their jobs, and they go back the next year and they do the test, with the test kits Ricky sells, and they go, look, the iron content hasn't increased, this hasn't happened, that hasn't happened, the water quality is still perfect, and it goes to show that if you take that bit more care over it and you just go to it with a bit more of a scientific idea behind it and what you're looking for and what you're testing for, then you can't really go wrong. It's everything's going wrong because we're not testing, we're not following best practice, we're not, like I said, you can't just chuck stuff in and hope it's going to work, because if you're chucking stuff in, what was there before you chuck that stuff in? If you don't know, you could add to that problem, especially if there's another chemical inhibitor there that doesn't react well with the chemical inhibitor that you're putting in. You're going to make the situation worse. So it's just one of those things where, it's just taking that bit more care, and, we're all guilty of it. I mean, we've all thrown systems in, we've all done that, but I hope we've seen the damage that does, because like I said, you can recover systems, but bloody hell is it hard work recovering systems once you've not, you've not just spent that time up front to get it right in the first place. What do we want to recover systems for? Just get it right in the initial steps, just as you're doing that boiler, and it's going to be perfect for the rest of its life. So I don't know, it's difficult for me, and it's just part of the process. None of us are perfect.
No, that's what gets me about some of the big boiler manufacturers. They've got service departments now. They're issued with one of the main brand test kits on the market. They're going out, and I think one of them told me it was £65 to put a bottle of, sorry, you've got no inhibitor in here. It's £65. We can redose it. So whack a bottle of this main brand inhibitor in, but they don't realise there's always a nitrate. There could be the other brand in there. It's got a nitrate in it. And then 6 months later, we're on the phone, the boiler's leaking. Diverter's shot itself. And then they're going back now to try and recover it. But they'll put another diverter in, but they won't upgrade that system and pay for the flush to get it all better.
I mean, don't forget, as our heating, I was just going to say, sorry, as our heating industry kind of expands more and more and more, and technology gets more and more and more, you know, we've been historically asked to do everything as heating engineers. I mean, now they're talking about design and build under Part L and all sorts of things like that, and heat loss cups, which I'm into, and you know, design and all that kind of thing. I mean, it's you can't physically do it all. You know, it's kind of almost impossible to try and do it all. So I mean, I know at least 2 guys now that have actually given up off the tools now. They don't do any tools work now, but they just go out and do water quality works and maybe a bit of boiler servicing. That's all they're doing. And I think that makes this industry really quite interesting then, because it means there's just so many more opportunities that have been presented, you know, with this, that people want to specialize in. And you know, I mean that's certainly exactly what they do in Germany and France and everything. You get flue specialists, you get water specialists, you get gas pipework specialists, you get all of that. You know, if you know, it depends what you want to do with your life. If you just want to go around and just fit boilers, or you want to go around and just do pipe work and that kind of thing, then you can. You know, and I don't see that. I just see it as a great opportunity, not anything else.
Yeah, it all comes down to cost. The problem with that is people don't want to pay it, do they? You know, you get, and that's all you'll ever get back about what I do and whatnot is people don't want to pay it. Like, why should I do that? It's that bit.
This is part of the education process, isn't it?
Yeah.
And I find that more and more and more people, the more you talk to them and you say to them, listen, you do realize, you know, that would you want me to put, you know, an acidic soup in your heating system to let it run that you've just paid, you know, 20 grand for? You know, would you want me to just put an acidic soup in that's going to rot it out in 5 years, or would you like me to actually get the science behind it and actually treat that water so that system could last 30, 40, 50 years? You know, I mean, and people just go, do you know what? Yeah, how much is it going to cost? You know, and then you know, when you add it up, it's not as yes, it's more. Of course, it's more, but then you know, so is buying a new car and not changing the oil frequently, isn't it, and doing all these sorts of things.
That's what I say to my customers. If you walk in a job to do a quote for a boiler exchange, walk in with a test kit and your pressure gauge and your weigh cup, you've virtually nailed it, haven't you?
Yeah.
So you whack that on the kitchen side with your little sheet and off you go and do a few bits. You just start talking to them, educate them, and then you've pretty much secured the deal. Yeah. I don't think they start questioning you.
And to be fair, how many of them actually really care about the water quality? It's rare. I'll go out, I'll talk to them, explain what's what, and then I send my quote across, and it'll have attachments with it, what they can read through. So I'll have one discussing water quality and whatnot. I've never really had probably a handful of people that's actually been interested and said they've chose me because I've gone that way. But a lot of the time, they don't know what I'm putting in or not anyway. And
Damon, can you share those documents that you just talked about there? Would you share those with the guys? Would you share those with me so that I can put them on the group for people to read?
Yeah, if I could find them.
You don't have to do it now, but if you can send them to me, because that would probably be really useful.
Oh, yeah, I can email them through after.
That would be really cool, because I think that would be really useful, because then they can read it and it gives them the education of how they can talk to their customers about it, isn't it? And that then gives them the justification for that extra charge.
Yeah.
There's a question here about rate. Go on.
I'm just saying the charge isn't really the initial unit is itself, but as Vicky mentioned, you buy tools all the time, you buy a new van, it's a company asset. Once you've got it, you don't need to change it. All you're doing is topping up your resin. And then, like I said, around my area, it costs me about 10p a litre to fill, which is no more than what a bottle, I say, 100 litre system, £10, bottle of niblet is £10. It's no difference for me. They've got this idea, I think, where they've seen these fancy machines, whatnot, on Instagram and £1,500 and these cartridges that are mega expensive and think you need to do that. But you don't. There's a way around it and doing it, and it's just learning and seeing what's best way for you to choose how you want to do it. I mean, you can get them little top-up cartridges that it's got, and you could fill with them if you needed, and just replace your cartridge at bottom. That's £150. And your cartridge top-up's about £40, I think. That'd get you a system done. Then you can just take it to your next job and fill up. I carry around just for filling up on services if I need to, and just topping up. But
so the VDI with the little filling tube, that can be used on more. That's not just a one-off.
No, you can take it.
The resin.
No, the resin will last more than one job in most instances.
Yeah.
Right. Okay.
Yeah, depending on the size of the system and your incoming water main. So you'd need to know the resin will expel and only be used for certain like quality of water. The better the quality of water, the longer it'll work. But if it's got to work harder to change that water quality, then you'll get less use out of it, for example.
Right, okay. And there was a question earlier from, I think it was from Paul Spence about radiators. And he said, is VDI supported by radiator manufacturers?
I think they ask for inhibitor, but if you're looking like 𝗺𝗺𝗺𝗀𝗺's instructions, they actually ask for VDI. So their warrant is then supported by inhibitor. If you're doing your VDI properly, you've got I'd argue to my death, there's no problem with the radiator. If you've got the right water quality, then what's causing that corrosion?
Yeah, I think you could argue with him. Even 𝗵𝗲𝗁𝗺𝗁𝗺's website stipulate VDI conditioned water.
Yeah.
So
a lot of people they don't turn up and say, "Oh, you've got inhibitor in your system. We're not changing your boiler pump."
I'd like to add to that. The radiator standard that we all calculate to now is EN 442. That's a European standard, and there are millions and millions and millions of more radiators out in Europe than there are here, and most of those are all done to a VDI or a different system. So I don't think there'd be any issue whatsoever with that. I mean, warranties. If you're getting a radiator that's rotting out, it's going to be because of either the water quality or you've got oxygen ingress coming into that.
If you've got that at one radiator at that stage, you're looking at more of a system issue. You're going to have problems with your boiler. It's not just going to target the radiator. If your system's getting to that bad degradation, then you've got issues. You've got major issues somewhere else. I've now got 4.5 years doing this. Tap filled for about a year, and then went to the resin. I've got no issues with any radiators, any boilers, no warranty calls on them. It spoke for itself for me. It's I can't see why you wouldn't do it. It all goes down to person and whether they want to do it.
You find most radiator failures are down to taking them off when you're decorating, plasterers are in, and not commissioning the system. So basically, you go in, and we've all done it. You're refurbing a house, you fill the system up, you leave it full of water for a week, pressure testing it. Yeah. They're getting eaten by oxygen, and then you take them off, drain them off, leave them for about a month. So all that oxygen's attacking it. It usually hits a weld, so it's the weakest part, and it'll attack that. And then you've got then you put them back on, you fill it back up again. They might be off again, empty again, and then they're back on. And then a year later, they started splitting at the weld, usually at the seam, and that is just down to not commissioning the system properly.
And that's my big problem with underflow heating. You go and fill your underflow, you fill it with water. You can't drain that water out. That water's always going to be in there then, because you can't get a lower point than that. And then you just turn it. That could be stood there for 2-3 months. And then you just turn your system on, and all that water's going round. Because no matter what you said, and they don't that underflow water don't get flushed once that's filled. You just turn that system on, then do that. So I air test now on underflow heating. I don't put any water in. Yeah,
but also, I mean, again is an expansion issue as well. It's always if expansion is not right, and your boiler fires up, and there's no expansion left in the vessel itself, that system will pressurize up to at least 3 bar before it.
Well, we mentioned earlier boiler breakdowns. I'd say you're touching probably 95% due to expansion, water, and air ingress.
Yeah.
I think you get them right, you then only leaving really electrical faults or just a part failure, which is down to the manufacturer.
Yeah.
That's what I don't understand about the big service companies not servicing expansion vessels.
You get them done, then you're fine. Expansions and services every year not being done properly.
Imagine these massive companies service a vessel every year on a service that just knock 40% straight out the window with the breakdowns.
Yeah, they would.
I don't know why they don't do it.
No one does though, do they? I mean, I watch Ian IRB. He's always doing his expansion vessels, isn't he? Every single job I see him do, like on Insta, he just makes a big point of making sure checking your expansion vessels, and the amount he replaces as well. Where other people haven't bothered doing the expansion vessel checks every year, and he ends up changing the vessels out. But just goes to show the importance. They're there for a reason, and normally they're undersized because no one ever calculates out system volume and then puts the correct expansion with it. So that's one of the biggest issues we got. And most manufacturers of boilers will give you a really small expansion vessel. You know, there's lots of companies out there with only 6 litre expansion vessels, and then they're not sufficient for a system that is 100 litres or more. So, you know, got to, there's loads more behind it, isn't there? You know, the water quality is one port of call of the whole system, but, you know, expansion vessels really key critical, making sure you know, that system's definitely got enough expansion, because like the guy said, if there's not, you're going to have problems not only just with water quality, but with the system itself and its longevity. So.
Filling it right, setting it to the right pressure, and also pump position of the expansion vessel. I mean, how many times you see an expansion vessel on the system and it's in wrong place?
Yeah.
No one knows like where neutral zone is. They just put them wherever they want to put them.
That's what JMR Heating was saying at 7:36. He said expansion up the pumps, well, backside, I guess.
Oh yeah, I told you.
Come on, JMR. You know better than that, mate. Up there, it's the neutral point, mate. The neutral point.
Yeah, it's the other thing, isn't it? Like an isolation valve on a vessel, because you know you can't recharge them without draining the system off.
Yeah, 100%. Yeah. And
you just go there. Every new build you go to has got a red vessel up in the cupboard, and it's just straight on the valve with the filling loop on it, and you've got to literally
pressurize it.
Yeah, and you just think, what is the point? It's a 15
flexor.
Yeah, it's a 15 quid valve just to service it, and all these little problems just disappear when that's done every year.
Yeah, crazy. I do cover a lot more of the expansion now in the training that I give. If anybody wants to come on, that's the only advert I'll ever do. Oh, sorry, Claire.
That's okay. Advert way, Rob.
Really important though, you know, the expansion vessel is very underrated, you know, and we don't do any of the science or the engineering behind it that's required, you know, and because you're assuming the boiler manufacturer's doing it for you, you know, when you put a combi boiler on the wall, you kind of assume they've kind of done most of it, but when you realise that actually the expansion vessels are massively undersized for most systems, you know, and for a boiler manufacturer, it's a cost saving exercise. At the end of the day, you know, we keep asking for cheaper and cheaper boilers, and that's the result of it. You want a cheaper boiler, that's what you've got. You've got an undersized expansion vessel in every single system, you know. And
in the cupboard,
it would actually make more sense for them not to put the expansion vessels in the boiler, because they're never calculated for the system, and actually replace that and stick something like a deaerator in it, or a vacuum degassing unit in the side of it, or something. Do you know what I mean? In the side of the boiler.
Much better.
Yeah,
of course. The challenge was on, wasn't it, a few years ago? Who can get a boiler in the side of Howden's kitchen cupboard? So they all seem to like, I can get it 270 deep. I can get this vessel 4.5, 5 litres. But it's like, what do you recharge your vessel to in the loft? You don't want it at 1 bar, do you?
No, this is the whole point. This is why the calculation. This is why the calculation. Yeah. That's
even why when you've got 6 meters above you, what are you putting it to? Then we've got into this idea of the system's 1 bar. But if you look at like system pressure as well as your height changes, then you don't want to be 1 bar. You want to be more. You want to be higher, depending on vessel position as well. So there's more into it.
But as Ricky
again, as with everything, we just get the easy way for everything.
Easy way through. I mean, as Ricky's saying there, like if the boiler they're trying to get it into a kitchen cupboard or something along those lines, and you can't get the expansion vessel near to the boiler or something like that, and you do have to put it upstairs, you've got to calculate the static height of that building and take that out of the equation, you know, and always keep those vessels around 0.2 bar higher than that static height, you know, to do. But it's a very, very simple mathematical equation to work it out. But it's getting the right size, and so you can't. This is a one. You know, you never hear me say oversized much, but you can't oversize an expansion vessel. Really,
simple until you get Derek involved.
Sorry.
Simple until you get Derek involved.
Right. Yeah, I know. But Derek goes into the massive. And you could spend a week learning about expansion, couldn't you? You know, I mean, I've tried to sort of throttle Derek back a little bit to try and get it into kind of sort of coalface engineer speak, which is quite difficult with Derek. But he's so lovely, isn't he?
You just need your domestic house, don't you? Really, not a rule of thumb, but get it domestic, get it simple, and you can get it out there. Because I see ATAG have just released a bulletin about expansion vessel sizing and positioning and places like that.
Yeah, I was talking to him about it when I was up there with him back in the end of the summer. But Yeah, I mean, I say this all the time, and you've heard me say this, Ricky, when you've been down on some of the gigs that I do, is that, for about 40, 50 years, we've been hitting the complete opposite wall to what we actually really need to be hitting for accuracy and design. Our job now as engineers is just, let's just stop hitting the wrong wall. Let's at least hit the right wall, and then we can get better and better and better at squeezing it down and getting closer to the bullseye target of what we want.
There's some interesting radiator company questions coming up and or statements. I'm not sure what it is, but yeah, I mean, ultimately with the VDI stuff, if it's all correct, I don't know what the radiator companies are worrying about really, unless they've got faults in their manufacture.
They certainly.
Because what would they prefer? What would they prefer? Chuck two different sorts of chemical inhibitors into the system and let it all corrode to death, or would they prefer a bit of science taken behind it and get the right water quality in their radiators? It's what I don't get. I mean, if you were to go back and ask those radiator companies actually what they're looking for, I don't think they would actually know themselves. So
no, I'd like to know what we're actually issue with that radiator and why. At the minute, I've got one with 9 big cast iron rads that are all going to be flushed and VDI'd. It's not crossed my mind not to do it. I'd argue to death with him. It
doesn't. Well, that's the thing. It doesn't matter what it is, does it? If it's metal. Sorry, mate. I was going to say, if it's metal and it's treated correctly for the correct metals in the system and the correct pH values and the correct, if you get everything correct and all your ducts lined up, what's the issue? There shouldn't be an issue. It's
no.
I don't know.
Anyway, don't it? And we inhibit it, taking it down to neutral way.
Yeah, we're only trying to create passivity within a system. It's like you would want wherever you go. If you go into a restaurant, it's too hot or it's too cold or it's this, that, and you want to get out and you don't go there again. It's the same thing in a heating system. You want it comfortable. You want it in its sweet spot, and the sweet spot is not just about maintaining the heat or setting up the heat, the heat pump or the boiler or anything like that. It's this cheapest component that is causing pretty much all of the bloody problems that we're getting with heating systems, and we're not dealing with it.
I always try and keep it simple. I always think about it like going on holiday. When you go on holiday and you go out there and you're white, right? And then you're on holiday for a week or two and you start browning off, don't you? Because your body's naturally passivating, yeah? So we're sort of going passive, yeah? And it's a bit like what we're trying to do inside heating systems. Do you know what I mean? When when you're on holiday for a couple of weeks, you don't start burning after a couple of weeks because your own body's starting to naturally, fight against that. And it's exactly the same as your... Do you know what I mean? It's exactly the same as the metals inside your heating system. If you get them to the right values, they'll passivate themselves internally, and that will stop the corrosion. So that's what we're trying to do. And exactly like going on holiday for a couple of weeks, and you passivate yourself by the what's it called? Is it melatonin or something like that?
Melanin. Yeah.
Melanin. There you go. But yeah, that's it. And, it's exactly like that. So if you think about your heating system on the inside doing that and passivating and then protecting itself, that's ultimately what we're doing with the VDI. So, and it's a really good method. And as long as you keep on top of it, like I know Damon's really religious about some of his stuff that he goes out to. And, as long as you just keep on top of it, just monitor it, everything else, you should never have a problem. And, the systems speak for themselves. So
the thing is, you'll have a starting point and then you can test every year. So if then you do see, for some reason it's out, something's happening that past year. If you see your iron levels creeping up, you can get to that root of that problem before they start being a problem.
Yeah.
And you've got a way to check in with other ways in an inhibit. You've got nothing to base what's going on in that system off, apart from getting a little app on your phone and getting a tick saying system's fine. I mean, it doesn't tell you anything.
What I would say to people about the VDI, VDI just isn't water quality. It's system design as well. So it's about the correct pressurization, all your design of the whole system. The key to VDI is stopping oxygen ingress with any water treatment.
Yes,
nothing against what. Like I've got inhibited systems work fine for years. They get serviced every year, not an issue. But because I know what's in it and I monitor it. But you've got to stop oxygen ingress. As soon as you put oxygen in any system, it's gone tits up.
Yeah, which is a lot, like we said, a lot of filling. You don't want them to be filling. 2 times a year, I'd say probably top up a little bit. If your boiler's losing all that pressure, get it sorted straight away. Don't be putting that in. And then you've got your auto air vent open, your system drops pressure, all that air's been sucked into that already.
Because some boiler manufacturers now have put these little drip pipes on the auto air vent off the back top of the pump. And apparently, I was at a training centre when they launched this new boiler 4 years ago nearly, and it was to stop
hydrogen
explosive combustion from hydrogen gathering in the chamber. And you think, what you're selling a product now, just get the water quality right, and you'll take that away.
Take that away.
Just sort it out in the first place, isn't it?
Exactly.
Yeah, that's it. Yeah, and I noticed another one. There's another manufacturer doing it now as well, so they're obviously having issues somewhere. But I don't know if it's still on, if it's on the European boilers. But I just look at I try and get the boiler manufacturer's instructions for the UK, then compare it with a European one, and it's just totally different. The parameters they just all say get it in this range for like some don't even mention VDI. They just talk about hardness of water and where to get it in like parts per million hardness.
You don't have to follow VDI. You can do it yourself, like and do bits. Just control your water and you control your corrosion.
Yeah, VDI is quite a complex document when you look into it. Or the back of it, you got to have water meters fitted to top up water no more than 5%, and it's quite complex. But just condition your water. That's what I say. Conditioning and monitoring is the key for domestic installs anyway. If you go into commercial big buildings, you need to look at other methods like electrical chemistry and stuff like that, anodes and reaction tanks.
Yeah. I mean, can I just add, we were talking earlier on, just when we touched on Henry's law. If you do that experiment with the glass on your bedside and look at the bubbles in the morning, just very, very gently pick that glass up and take it and put it back in the fridge. Or put it in the fridge. And I'll tell you what, go back there and have a look in an hour's time, right? And there won't be any bubbles in there. That'll all sucked straight back into the water. It's quite an interesting thing to open your eyes to this and how this is happening inside your heating system all the time.
Day in, day out.
Yeah, exactly.
So like low temp, I think low temp, that's going to slow corrosion down, isn't it? But obviously, we've got to get the pH up, get the water quality right. But I think that's going to help. Imagine these systems, boilers are now at 80 degrees, 85, some of them out the box.
Yeah.
I think they're just stressing all day, aren't they?
This is why you're going to need vacuum degassing in the future. So systems, as you go to low temp, anything that is now more high tech is also more high risk. And that's the same with kind of anything right the way through the system, through design and stuff like that. The more involved it is, generally the more risky it is. That's the thing. So vacuum degassing. We're trying to build a unit at the moment but it's still going to come in at around sort of 1,500 quid. I think what you're going to find is water treatment specialists that buy a unit, like a few guys have done now, and actually use it as a mobile unit and go around and just use it and do water quality as a service, and do it that way, and maybe do it once every sort of 3, 4, 5 months, something like that.
I've got a customer one in the pallet in his garage, never used it.
In what? He bought one?
Vacuum degasser.
I'm sure someone will buy it here. What is it? I might buy it.
It's an IMI one.
Is it?
Are you on about me?
No.
I can get those cheap anyway.
Just one thing. We were talking about those radiators earlier and the cast iron one, and the guy who mentioned it, which was Paul Spence, had said that the issue was a manufacturing fault, which was why he was worried about his warranty. There was a hole in the column and it leaked, first of all, which was why he brought up the subject of the inhibitor not being, them not covering it with the VDI.
Can you ask Paul, or we'll ask Paul, can you post up the answer to this, Paul? How quickly did this pinhole show itself? Did it show itself on your initial fill, or was it 6 months down the line? Was it what?
He said it leaked on that comment. He said the issue was with a manufacturing fault, pinhole in the column leaked on initial fill. Yeah.
So right, okay, right. I mean, what's that? I mean, that's just a manufacturer being idiots, aren't they? If it leaked on the initial fill, it's got nothing to do with VDI or nothing to do with chemicals or inhibitors or anything. And if blimey, I mean, they'd have a
I'd love to see them coming out and checking on site, and I'd like to see what water checks are actually doing with water on site. I'd be there. I'd get my test kit. I'd test with him and show him that it's not even possible to see what's happening. Yeah. At that point, the cast iron 𝗵𝗲 corrode, your system water would be orange as hell, and it'd be for that to eat out.
But well, I can tell you now, if that
I think he's just pointing to the fact that these manufacturers just trying to get out warranty and just using VDI and things like that for the excuse of out the warranties.
If that had been on a job that I'd specified and that had leaked on initial fill, I can promise you they'd have had a very, very stern letter from my solicitor, and that would not have gone that way. There's no way that they've got to be called out. Any manufacturer that does that is frankly shocking.
Just spin them off, isn't it? I mean, the quicker you bin all the manufacturers off that do that, you know, it'll all balance itself out. It's kind of that universal thing, isn't it? Do you know what I mean? While you carry on supporting these people that do that they'll carry on doing it. Do you know what I mean? It's when you stop supporting these people, then they'll have two choices. They'll have to change and support what you're doing, or they'll die. You know, there's two ways. So. Well,
industry is kind of led from the people within it if you push hard enough. And I mean, look, you know, Rich Burrows and myself and now Ricky and Damon and stuff like that. I mean, we've been fighting for years now to try and get choice within the system, to try and get more accountability, better understanding, better system design, and actually stop our tick box culture that we've had for the last 50 odd years. You know, it's very, very difficult to move forward. You know, I mean, I think I don't know if that was Paul again, but he said unless VDI is given equal status to inhibitor, it's a get out clause, and I totally get that. But voices are changing, and what we need guys like you that are listening to this now to start joining, get onto some of the forums that we all talk about this stuff, and get a critical mass going. Once you start getting a critical mass, and these manufacturers and the rest of it, they start getting lots of feedback from more and more and more people, it will change, but it's going to take time.
Offering letting people use the VDI for water. I think 𝗵𝗲 are going back to that in UK now, and that's come from people pushing stuff.
Alpha as well, Damo. I was chatting to Phil Jones the other day, and Alpha are bringing in, they'll allow non-inhibitor based chemical, water treatment, so instead of chemical water treatment. So it's, it is coming. And
like Phil's app manufacturers to start with an E and an A tag to start raising them issues. At 𝗵𝗲, I think it was due to Craig Brooks. He'd done a VDI system and he'd walked out and bottle inhibitor in his system. And then he's like, what you do with that? And then he got took higher, and now 𝗵𝗲 looking at that stuff. So things are moving in that way.
In the right direction.
Yeah.
Yeah.
I think the manufacturers have got to educate their engineers that are coming out to service what VDI is. And we've possibly got to make these appliances with massive stickers on saying chemical free or do something, because they don't know what they're doing with them, do they?
Yeah.
Just top them up with inhibitor.
I mean, you do know one thing. I just will say we've just launched our digital cloud-based storage now. So any of this documentation can be put onto the system, and you'll have it within the property forever, and that so you can keep monitoring this. And anybody with a QR code scanner like your phone or something can just get all that information. But I'm just looking at what Paul was saying again. In my instance, the merchant stood the cost. I mean, I've had this before, Paul, and I frankly, look, the merchants are doing that because they want to keep your business, and good for them. It's brilliant, but they're taking these knocks on the chin. They shouldn't have to take those knocks on the chin from something that is a manufacturer's failure. Of course they should. It's disgraceful.
Honestly, just bin them all off. Get the merchants to bin them all off. I mean, I don't sell anything I don't want to sell. If it's crap, I won't sell it. It's that simple. So, we're just going through it at the moment. I took some ranges on. I'm going to bin them all off because we're not getting the response back that I want to get back from our stuff. So, like I said, it's up. You've got a choice out there at the end of the day. Customers might want one thing, but ultimately the decision can be yours. If you turn around to them and say, look, I can fit all these rads for you, but if anything goes wrong, they're going to try and get out of the warranties. that customer won't have that manufacturer. It's that simple. You know, you can have this choice. You know, there is this choice out there, and you know, you think we're not powerful. We can be, but you know, it's up to you, the merchant, the next chain, to all stand up together and go against it. And once that happens, things will start changing. While we're happy throwing stuff in that, you know, and these manufacturers keep getting away with it, they won't stand it. You know.
It's what I say to these people who've got issues with a warranty and a manufacturer. Just ask them for the water parameters, because they won't give you them, because they haven't got a clue. They haven't got a clue what they're talking about with water quality. All the boiler manufacturers have not got a clue. As soon as you ask them what the parameters are for the set guidance for the water, you've not a chance, hell in hope of getting it. So you need to
maybe that's the key thing from or one of the key things from this meeting is that ask your manufacturers or ask your radiator companies to say, well, what is your water parameters? What is it that you want? Get it in writing from them, because if they can't even give that to you in writing, we'll say, well, hang on a second, why will you not accept this then?
Yeah.
If you don't know what the answer is, then you know.
What are they actually testing for on the inhibitor when they go out to this? Is it what? Because if you got, they'll check the clarity of water. They check, is the inhibitor present?
Yeah.
What presence of inhibitor are they wanting for them systems? What for that right down much inhibitor do you want?
I know how much trouble Ricky's had just trying to find out the basic information. So if Ricky's actually spent time and effort trying to look for the details and the devil behind it, and he can't find it, no hope in hell of the manufacturer is going to find it.
Yeah,
trust me.
No chance.
They're not going to put the effort in. They are not.
You know what? Some of these issues could be bacteria. So you get bacteria growth underneath, and it could. And there's I can guarantee you that there won't be one person in the UK testing for bacteria. No. You've literally got to take these slides, put them in, and leave an incubator on site for about so many days, and you've got to monitor it every day. So you lift it out and look for this little black thing, then it starts going from pink to orange, I think. But you've got to keep it at 30 degrees. You can't travel with it. You can get in-car charges, but bacterial, so you get like NRBs, nitrite reducing bacteria, which probably loves inhibitor because there's nitrite in some inhibitors. Yeah. So that's causing some of these issues, but it just gets put down to corrosion. There's all sorts when you look into it, and it's just a minefield out there.
Yeah, for sure.
But I think deeming water just takes a lot of these issues away.
Yeah.
Myself personally, incorrect commissioning.
You know, like a certain brand of inhibitor put on Instagram for a week that just adding a bottle of inhibitor to your system will save you 15%. Like
15% of what?
30.
15% of what?
Your energy bill.
I will raise your efficiency by 15%.
Right.
Your heating system, which then will be directly related to your bills and whatnot. And that's coming from the manufacturer itself.
I did see that. I did get some people sent the link to me, and I just laughed. It's from one of the biggest in the world as well, isn't it?
Yeah, is it?
It said it did say it's all laboratory sorted, so they've obviously found the worst system they could in the world.
Yeah.
Cleaned it out, flushed it, cleaned it, and put some inhibitor in, and said 15%.
It's crazy.
What I'll say about the merchant comment there is that, trust me, you don't buy stuff off merchants, they won't stock it. Believe you me. So, you know, while people are still buying it, they'll stock it. So, you know, but you won't get a merchant out there that won't sell anything, then, you know, won't stock anything that they're not selling, trust me. So, you know, believe me, when I want to invest £100,000 in stock and goods and products, I'll invest it in stuff that sells. So, you know, same as anyone would. It's like money in the bank. You know, you invest it in the things that make you the most money and the things that are selling. So if they don't sell, you won't invest in them. So it's up to you installers out there not to buy the stuff or fit the stuff that, you know, if they're rejecting you, which is what it is, it's a direct rejection from the manufacturer. If they're doing that to you, don't touch their stuff. It's that simple. Exactly. I can't make it any simpler than that. It's like a boiler. If you fitted a boiler and they came out and they criticised your work, would you ever fit that boiler again? You wouldn't, would you? So it's, you know, it's one of those, isn't it? So, you know, it's just, you know, you've got the power, you know.
Make the stand,
just make the stand, you know, that's it. Make the stand and, you know, do what you got to do. You know, at the end of the day, you've got to make money. You know, at the end of the day, the guys here today guiding you in what you can do and what's possible. But, you know, ultimately it's up to you to choose how you want to take it or how you want to go with it. So, you know, And, you know, I appreciate some of the guys out there that have been doing the water quality off their own backs and not using inhibitors have had to stand it because the man haven't supported them. But this is what we've tried to do, is get the manufacturers on board with the water quality and the checks and the just making that alternative, like Damo said with 𝗵𝗲𝗁, just make sure they've got that alternative there, that if you want to do it, you can do it, and that they'll support you. If they won't support you, don't use them. You know, it's because what you'll find is in the European countries, they're supporting this. It's only the UK market they're not supporting it in. So, you know, you just need to ask the questions why. Why are you supporting this in Germany and Netherlands and all these other countries out there? Why do you support it in those countries and not this? So, you know, and it, you know, we had the same thing with heat pumps as well. You know, we had this thing a little while ago where I think it was 𝗵𝗲𝗁. They were advertising in the UK boilers on their Twitter feeds and stuff like that, but on the socials in Europe, they had heat pumps on the Twitter profiles and that. So, and it was just like, well, why? What's the difference? Why are we different? Why? You know what I mean?
Sales.
Just try and get. That's it. It's all about sales.
That's all it comes down to. If you specifically went to manufacturer and asked them, really, good to 𝗬𝗲𝗃, good to anybody, like you said, why do you want me to put inhibitor in? Nobody could answer you. I've asked a few reps and none of them can answer you. Oh, we'll get back to you. Never get back to you. Like, they don't know. It's just being ingrained into the industry that this is what you need to do. And as we touched on before, it's drop your water, chemical flush, warm flush, cold flush, bottle inhibitor, job and gone. That you can do that in an hour, and that's supposed to make your system fine. And that comes from chemical companies. Like that has been, you don't get taught that by in your apprenticeship or when that's been like an industry made thing coming from these people that are selling you chemicals, and then come magnets after that when that process weren't working. And that it's just and now the testings come from that, because that process isn't working and warranties are now getting voided. So now they've brought out these apps that aren't universal, and you just pay to find their inhibitor in, but you don't know if their inhibitor's in, which will then tell you that you need to bottle their inhibitor, which will cost you more money and be detrimental to your system again. If you look, it's just a line of money just being made all the time by the same people with no care for system quality.
On that note, I'm going to say, let's wrap it up, guys. Thank you so much. I have to say, it's been really interesting. So much that I just, as a homeowner, had no clue about all of this stuff. So it's been really, really interesting.
You don't want to touch on flushing your valves or anything, no?
You what?
I was probably an hour and 20. I was going to say, do you want to touch on flushing your Drayton valves?
I think we can probably cover that on another one, because we've been on for a while and we might start losing people. But let's cover that another time, Ricky. But what I'm going to do is say thank you all for your time. It's been brilliant. Will Damon send me those documents that you send out to your customers, because I think that will be really useful for the installers that are watching. Rob, put the link to your training on, because you've mentioned that and some guys might want to come on and have a look at that. Richard, stick a link onto the shop again. And Ricky, if you want to put something onto your shop as well for the VDI stuff that you sell and the resin and all those bits and pieces, then feel free to put it in the chat on the or send it to me and I can if you're not on the group, Ricky, either way.
Yes, brilliant. Cheers, thank you.
And thank you all for your time, and we will see you hopefully next time.
Yeah.
Thank you.
Brilliant. Cheers.
Bye.
Thank you.